Statistical Tests Part 2, presented by Amy Horton for ELPA 7813. Statistical Test Part 2 includes the chi-square test, regression, and types of data required for tests. We begin with the chi-square goodness of fit. The chi-square is a non-parametric test of nominal or named data. The purpose of the test is to evaluate unpaired samples, also known as unrelated groups. The researcher asks a question about proportions in the population. More specifically, it uses sample data to test a hypothesis about the shape or proportions of a population distribution. Basically, it compares observed frequencies with the null hypothesis. Information is presented in a series of boxes, and each box represents a separate category. These are also known as two-way tables. It is important to remember that results may be limited when the number of subjects in any cell or box is low. The general rule of thumb is less than 5. The formula for calculating chi-square is the sum of the squared difference between the observed O and the expected E data, divided by the expected data in all possible categories. For example, a researcher wanted to know if there was any difference in the handedness of men and women. The researcher developed the null hypothesis and found the statistics that were expected if no difference. Then the researcher collected the actual data for right and left-handed men and women. Based on the data, there was no significant difference in handedness between men and women. Both seem equally likely to be right or left-handed. The chi-squared test does not seek to prove or disprove. It only serves to support or not to support the hypothesis. The chi-square test for independence is used to determine whether there is a significant association between two variables. The following conditions must be met in order to use a chi-square test for independence. First, the sampling method should be simple random sampling. Second, the variables under study should be categorical. Third, if the sample data are in a contingency table, the expected frequency count for each cell should be at least 5. Remember the rule of thumb. The 4 phases of the test begin with state the hypothesis. Next, formulate an analysis plan. Then, analyze sample data. And finally, interpret results. Chi-square distribution measures if the value is large or small. It's important to remember that the chi-square test adds square values. Therefore, it can never be negative. When the null hypothesis is true, you can expect the data to be close to the hypothesis. The values will be small when the null hypothesis is true. Chi-square distribution is normally positively skewed. 0 is seldomly found within the distribution of those statistics. The distribution uses critical values found on the chi-square distribution table. Another topic for statistical tests is regression. A line of regression defines a precise one-to-one relationship between each x value and its corresponding y value on a graph. The line of regression is drawn through the middle of data points on a graph. It shows a central tendency of a relationship. For example, if the line starts lower and runs upward to the right, it is a positive relationship. If it starts higher and runs down to the right, it is a negative relationship. The line of regression can also be used to predict future relationships based on the imaginary continuum of the line. A formula for regression is y equals bx plus a. The most common is linear regression. It starts with points, proceeds to a line, and regresses to points again. The diagram provides labels for the line of regression. An example of a line of regression would be a real estate agent who wishes to examine the relationship between the selling price of a home and its size. He selects a random sample of 10 houses. Y is the dependent variable, which represents the house price in the $1,000. The independent variable, or X, represents the square footage of the home. Based on the 10 points on the graph and the line of regression, we see a positive relationship between the cost of the house and its square footage. While there are other variables, these are the only two considered for this analysis. Lastly, we will describe the four types of data used in statistical testing. These include nominal, ordinal, interval, and continuous. Nominal data means having to do with names. It labels and categorizes observations. A nominal scale is a set of categories, each with a different name. Nominal data does not make any quantitative distinctions between observations. An example of nominal data would be if we wanted to know the gender of the person completing the survey. The two nominal scale categories would be male and female. While nominal data has to do with names, it can be represented as a number. For example, if you were to code it in SPSS, male may be given the numerical code of a 0 and a female as a 1. The numbers don't measure any kind of difference or assign any kind of order. They simply represent a category. Ordinal data refers to order. It is used to label and categorize, much like nominal data, but it differs because it then ranks the observations in size and magnitude. While it shows a difference, it does not specifically measure the amount of the difference. For example, an employer wants to rank employees in terms of how well they perform their work compared to each other. Jan is ranked as 1, Mark is 2, Richard is 3, and Sam is 4. Using ordinal data, we know that Jan is better than Mark, Richard, and Sam, but we don't know specifically how much better Jan is than Mark, Richard, or Sam. Interval data provides an ordered set of categories with equal intervals. Unlike ordinal data, interval data can measure how much difference there is between individual scores. For example, temperature as measured in Fahrenheit or Celsius. Each degree represents the same amount of heat regardless of where it occurs on the scale. Therefore, the difference between temperatures can be measured. For example, 52 degrees is hotter than 32 degrees. Continuous data can be divisible into an infinite number of fractional points. When using continuous data, it is important to remember that it is rare to obtain identical measurements for two different individuals. It uses what's called real limits. For example, if we wanted to categorize weight, we would consider 150 pounds as fitting into the category of 149.5 pounds to 150.5 pounds. It is likely that 10 people who weigh 150 pounds will still differ when weight is calculated to the tenth of a pound using real limits. After reviewing Statistical Test Part 2, think about and discuss the following questions. 1. What are the advantages of using a chi-square test? And what are the limitations? 2. What types of data do you plan to use in your dissertation? Why? Included here are the resources used for the presentation on Statistical Tests Part 2.